Okay. So I think we have basically gone through QMS systems and what the QMS system should look like. Okay. And it should have QP, QA, QC. Okay. So you have to have planning, you have to have project planning, with work breakdown, and then with resources, planning for resources in the quality manual, followed by, planning for checking, auditing, monitoring, and then the actual monitoring and QC. So that will be the whole system. Okay. I think it is actually quality is not as straightforward um, as time and cost management, because quality is more subjective. Okay. And there's a lot of parts that you may not be able to quantify. So therefore, when we talk about project quality planning, we will try to be as much as possible trying to work out on plans and manuals that are more quantitative based, and followed by checking that is more quantitative based. You see, we do not want to make it too subjective, like with descriptive kind of comments, or descriptive kind of checking. So anything descriptive will essentially going to affect the objectiveness of the results at the end of the day. See, and here I would like to put a side note, a special notes for quality management in construction. So project quality management. So basically, I think we need to understand that in quality management, there will be it's a lot more difficult in terms of quality management compared to manufacturing, okay, or mechanical in a way. Because quality management, our product basically from civil engineering is actually more diversified, you see, and then it is more difficult because our environment, the work is actually pretty much affected by the environment, like weather, like soil, like distance, locality, the ground conditions, all these things will actually affect the final results of the product we are building. So there's a lot of external constraints in that sense, you see. So no matter how much we specify or how much we want to be objective or how much we want to be very strict and disciplined, it tends to get lost. It tends to get lost in the middle of the whole project. And our project also lasts very long. There is another factor. So, and then your contractual relationship with different parties also will affect, it's not as simple as, not as straightforward. Like, I won't say manufacturing is straightforward, but you are in an enclosed environment. You have a specific supplier contract to supply the material, machinery contract, that. But us, in terms of civil engineering, there's a lot of construction, a lot of like different contractual relationship, and the team and behavior of people can be very diversified because you're dealing with a large range of people, and then you also have product diversity. So in terms of construction, it is difficult. It is difficult, and I think underlying uh we talk about underlying factors that affect the application of quality management are usually, like if a successful application, we will see that it's very objective. It's actually, there will be a lot of discipline from the leader, okay, and then there will actually be a lot of emphasis on also time and cost. There'll be actual emphasis on quality and given time to the client. The client gives you time to actually do a good quality plan and implement quality, work. And I think these are all the contributing factor: the pressure from the client, the leadership from leadership from the client, and then also the consultancy when they do the design. The engineers, when they do the design, they meet the client often enough. They actually sit down with the client often enough, and to actually see what is the requirement, the objective, the mission and vision, and the quality policy of the organization. And then they will do a design that is actually more befitting to what the client wants, see. And then when it comes to construction, you will definitely need a lot of discipline, a lot of monitoring discipline, a lot of data analysis discipline, a lot of willpower from the ground people, from the management team, in order to carry out quality management. So this will actually significantly apply to it will significantly apply to the successfulness of whether implementation of quality management is actually successful in the project. So in terms of application in the project, I want to show you some samples like how things can look like. Like I said, flowchart, this can be an overall, you can do something like this for an overall, you can write it down and explain some of this in details, but overall, we want to design a specific QMS systems whereby you are looking at specific ways of this is actually general way of looking the QMS systems for for what we call resources, okay? And then we also can have work activities as well. You can actually different kind of works, then different ways of looking at compliances and doing corrective actions, and this is a system. You see, when you can design these systems, of course you don't have to draw this in a very complicated flowchart, but you can have your own flow of thoughts, and so that when we read flowchart, it's actually all the time, it's a lot easier to understand, than just reading a lot of words in order for you to design. So I think a good tool to design would be flowchart. Then we'll go by work. So let's say we must know the actual, like for concreting work, we must know the objective of the concreting work, you see. Then we will specify certain material scale or certain criteria for you to look after, and then it must get approval, you see. Checking from approval, this is a visual checking, so you can write here maybe, is it visual checking or whatever, and then after that, or in this case, it goes down, they will tell you that you need this sort of certificates and all that, and then if yes, and then approval, based on what approval, you can put on the side what are the type of approval, and then if yes, you go to do the work, and then some more checking before proceeding to do the actual work, and then from the actual work, you still can have another type of flowchart, similarly with different type of stop, and then these are the things that you need to do. If not, then you go back and resubmit. You can design something like this, and it actually is based on the flow of work, you see. So you can have piling work as well. You can have for waterworks as well, you see. And these are actually more for the materials, product materials that you use the resources, but you can do similarly, you can do some for the work processes, you can have certain methods that is very important, and then you do a flow chart, and then if what are the inspection criteria for that particular section of the work, for example, and then if approval by the consultant, what are their acceptance limit, you can do something like this as a flow chart for like a project quality management system, which incorporate QP, QA, QC. So this is actually planning. So within planning, if you do have the checking and the flow and the remedial actions and all that, the remedial actions and rectification actions and how to bring things back and how to do monitoring and controlling. If you put it in a flowchart, essentially this is actually a QA. This one shouldn't be called a QC process. This is actually a flow of QA processes for water reticulation. But here we write QC because this is only one part of it. But if it's with including the work, this is more on material. Let's say if you have some for equipment, if you've got some for workmanship and activities, then the overall whole chart will be called a QA. It's a QA system, you see. So once you follow through this flow chart, meaning that then you are giving a form of assurance, a guarantee that your documentation is well done, your flow of work is thought through, your checking is all in place, people understand the objective, the quality objective of the project, and that's it. You are assuring that the product that comes out, or the subcomponents or the activities, ending of the activities is considered as good quality, and it's the desired level of quality because every part we check through carefully. So this is what we call a QA system, you see. And overall, this is a quality management system. Okay. So I hope that